Welcome to the debate. Today, we're diving into something pretty fundamental in software architecture. It's that constant push and pull, right, between squeezing every last drop of performance out of the machine, which you might associate with, say, C++, versus making life easier for developers, getting things built faster, which, often points towards Python.
Exactly. And it really forces a key question for anyone leading tech teams or designing systems now. What's the smarter bet for long-term business value? Do you go all in on optimizing the silicon with C++, or do you optimize the human element, the development speed, with something like Python?
Right. My stance is going to be that raw performance, that efficiency, isn't just a nice to have in certain critical areas. It's actually a non-negotiable prerequisite if you really want to dominate a market.
Mm-hmm. And I get that, I really do. But I'm coming at this from, well, almost the opposite angle. I'm going to argue that development velocity, how fast we can actually deliver and iterate, that's the crucial factor today. Our most expensive resource? Skilled developer time. And Python, I believe, wins by optimizing that resource for most applications out there.
Okay, let's maybe dig into what we mean by performance first, because it's more than just speed. It's really about resource efficiency and control. C++ is basically built for this. I mean, its whole design, compiled, statically typed, manual memory management, that all translates very directly into, well, lower operational costs. Needing fewer servers, smaller cloud bills for the same amount of work compared to interpreted languages.
Lower OPEX? Okay.
Yeah. But where it really shines, I think, is in predictability and low latency. If you look at really critical systems, high frequency trading, HFT comes to mind, where like milliseconds mean millions. Or maybe real-time control systems, robotics, that kind of thing. Microsecond level response times aren't just a feature, they're the table stakes. You have to have them. And C++ gives engineers that super granular control over the CPU cache, over memory layout, to practically guarantee that predictability. You avoid those unpredictable pauses you can sometimes get with automatic garbage collection in other languages. And look, for certain jobs, C++ isn't just a bit faster. It can literally be up to like 100 times faster than Python. When speed is the product, that gap is, well, it's basically an insurmountable competitive advantage.
Okay, 100 times faster. That's definitely compelling for those, let's call them edge cases or specialized domains. But let me bring it back to what I see as the reality for, the vast majority of software projects. Productivity. That's what I'm optimizing for. And by that, I mean minimizing the total time it takes for developers to get an idea into production and then maintain it. It's about optimizing that scarce resource, developer time, and focus.
Mm-hmm.
And Python just excels here. Its syntax is simpler, it's dynamic, and crucially, the ecosystem, the Python package index, PyPy, is enormous. It's got batteries included, right? Robust, pre-built tools for almost anything you can think of. Studies actually suggest the development cycle can be like 5 to 10 times faster than with C++. That speed, that velocity, gives you a massive time-to-market advantage. If you're a startup trying to find product-market fit before the cash runs out, or an established company racing a competitor to launch a new feature, Python's speed can be the deciding factor.
Right. Time to market is key there.
Totally. And we also can't ignore the long-term human cost. Python just lowers the cognitive load. Engineers can focus more on solving the actual business problem, not wrestling with pointers or memory management details or complex build systems. This human-centric approach, I think, fuels faster innovation because it makes experimenting cheap and easy. Ultimately, delivering more value more often beats shaving off milliseconds in most business contexts.
I definitely see the appeal of that speed, especially early on, getting that MVP out the door. But I want to push back a bit by looking at the total cost of ownership, the TCO. The whole life cycle cost. You're really focusing on lower initial development cost. But what happens when that Python service actually succeeds and needs to scale? Like, really scale?
Okay, fair question.
Those initial savings, they can get absolutely eaten up by infrastructure costs down the line. Python's lower efficiency, things like the GIL, the global interpreter lock, limiting true parallelism, the overhead of interpretation, it often forces you to just throw more hardware at the problem. You end up needing way more servers to handle the same workload that a C++ app could manage on potentially a fraction of the machines. So yeah, C++ might cost more upfront in developer time, but it often gives you a much flatter cost curve as you scale. Those early Python savings can turn into pretty big long-term liabilities on your cloud bill. And it's not just hardware. Think about bugs. C++'s static typing catches a whole class of errors at compile time, right there on the developer's machine, before it even gets close to production. Python's dynamic typing, well, it punts that risk down the road. You could have a costly type error lurking in some corner of the code that only shows up under heavy load in production months later. Static typing acts as a significant safety net, lowering the long-term cost and risk of runtime failures.
That's a good point about the operational TCO and static typing's benefits. I won't deny that. But have you really factored in the talent cost? I mean, isn't the biggest expense the thing most likely to actually kill a project or a startup? The cost and availability of specialized developers? Finding good C++ engineers, especially for those high-performance, low-latency areas you mentioned, it's notoriously hard and incredibly expensive.
It can be challenging, yes.
You brought up HFT, right? You hear about those C++ rules paying, what, 600K plus. That creates a massive initial barrier. It dramatically inflates the initial TCO for C++, arguably much more than potential future server savings. For most companies, I'd argue the cost of just finding, hiring, and keeping those specialized C++ experts far outweighs the potential savings on cloud instances down the line. We talk about Python risking performance debt needing to optimize later, sure, but C++ runs a huge risk of debilitating complexity debt right from day one.
Okay, complexity debt. Let's explore that. What does that look like?
Well, it manifests in a few ways, right? Slow build times, for one, which just kills developer productivity and iteration speed. It makes onboarding new team members really hard because the code base can be, intricate, demanding deep knowledge of memory management, resource lifetimes, all that stuff. And maybe the scariest part is the constant risk of subtle, really hard to debug bugs stemming from manual memory errors, use after free, double deletes, leaks. This complexity can lead to a brittle system that's just slow and painful to change or add features to. And for most businesses building web services or enterprise apps, the risk of being slow to deliver features is actually much higher than the risk of the code itself running a bit slower.
I agree the risk of complexity debt with C++ is real. It absolutely needs careful management, good architecture, skilled engineers. But that risk doesn't just erase the need for C++ in certain domains. Let's contrast the needs again, right? Think about a AAA game engine. It has to hit that, 16 millisecond frame budget for 60 FPS. If it misses, the product is fundamentally broken. C++ is pretty much mandatory there.
Yeah, for games, sure.
But then you take a typical SaaS backend. Like you said, it's often I/O bound anyway, waiting on the database, waiting on network calls. Python speed is usually perfectly fine, sufficient, as you put it. In that world, the time to market advantage is king, and that potential 100x compute speed difference is just irrelevant. We have to acknowledge there are whole classes of systems where that precise hardware interaction, that predictable timing is the core value. The second you need deterministic, sub-millisecond timing, or direct hardware control, C++ shifts from being an option to being, well, a basic requirement.
Absolutely. And I think that leads us right into what feels like the practical reality today, which the source material seems to acknowledge too. This whole debate is kind of dissolving in practice because the hybrid model is so dominant. But I'd argue this doesn't prove C++'s dominance. Rather, it shows how it's often being, let's say, wrapped or managed by Python for productivity.
Interesting framing.
Look at data science, AI, massively compute-intensive fields where Python reigns supreme. Why? Think about NumPy, TensorFlow, PyTorch. These are giants handling insane amounts of parallel computation. But the data scientist, the researcher, they're almost always writing Python. The heavy lifting, the core matrix math, yeah, that's done by highly optimized C++ or CUDA kernels underneath. Python acts as this incredibly productive, high-level interface, letting domain experts focus on the models, the algorithms, not the low-level plumbing. It lets them experiment rapidly. C++ is the engine, but Python's driving the car, you know?
Okay, I agree the hybrid model is the dominant reality, but I'd frame it differently. I'd say this partnership actually reinforces C++'s fundamental necessity. It doesn't relegate it. C++ is still the indispensable engine, providing the actual horsepower. Without that C++ core, Python in these domains would just, well, it would fall over. It couldn't handle the load.
Fair point.
So the real strategic decision isn't if you need C++ somewhere in your stack, especially for performance critical paths, but where exactly you draw that boundary. The line between the flexible Python logic layer and the optimized C++ performance core. And that's why tools like PyBind 11 or Cython are so important strategically. They exist precisely to manage that interface, to let you call fast C++ code easily from Python. You're essentially choosing to pay the complexity cost only where it's absolutely unavoidable for that critical performance path.
Managing the boundary.
Exactly. And this gives us a pretty clear decision framework, I think. You look at the project's primary driver. Is performance criticality high, like embedded systems, core network infrastructure, HFT? Then C++ has to be your starting point, your foundation. But if time to market pressure is high, which covers most web apps, data pipelines, startups, MVPs, then Python should be the default. You start there. And you only optimize parts into C++ if and only if you prove a real bottleneck exists in production. The strategy is dictated by which axis, speed of computation or speed of development, drives business success for that specific project.
And that framework, I think, circles back to my core argument. For the vast majority of modern software, optimizing the human time with Python's productivity offers a much bigger competitive edge and better overall business value than optimizing machine time. The opportunity cost of slow development, missing your market window, competitors beating you to features that usually dwarfs the incremental cost of running Python on slightly more hardware. That whole low latency, 100x speed advantage, it just doesn't matter that much when your app spends most of its time waiting for the network anyway.
I still maintain, though, that for those foundational systems, the engines powering high-value domains, the core infrastructure needing predictability, anything touching hardware directly, C++ holds an absolutely critical non-negotiable spot. In those niches, speed, predictability, resource control, they are the product. And the higher upfront investment in C++ talent and managing complexity is just the necessary cost of entry and long-term efficiency.
So it sounds like we agree the smartest approach often involves using both strategically.
Right. The real takeaway, I think, is that the best tech organizations know how to build systems that leverage the strengths of both. Use Python's agility for the bulk of the application, for rapid innovation, for the user interface, for the business logic, but reserve C++'s raw power for those specific, usually small, parts of the code where speed is absolutely paramount.
Yeah, the challenge isn't picking a winner between Python and C++. It's about understanding where to draw that line. How to manage that boundary effectively to get the best of both worlds, the speed of the developer and the speed of the machine.
Exactly. Mastering the boundary management, not just choosing a tool.
A very nuanced place to land. This has been a great discussion, really clarifying the trade-offs.
Agreed. Thank you. It really highlights the complex factors driving these critical architectural choices.